piecewise functions, our steps go as follows. Number 1. Ignore. No, just kidding. Don't write that. I feel like that was too complicated. Where's my pretty? Oh, it came over here. Draw a line for each, that's an A, not a Q, each equation. So we're going to graph each equation. Shh. We're going to graph each equation. And then we are going to find our endpoints. And draw an open circle or a closed circle. Oh, guys, warn me. An open circle looks like this. Closed looks like this. And then on your sections, you're going to erase the rest of the graph. Erase rest of the line. If it looks like this or like this, we're going to keep the left. If it looks like this or like this, we're going to keep the right. Okay, this probably looks confusing, but as we do it, you're going to get it. You will. I trust in you. So we're going to do this one as green. Well, I'm going to do this one as green. You choose a color. This one's going to be blue. Okay. So when we graph 3x plus 1, what type of equation is that? Yes, slope-intercept. Good catch. That's a slope-intercept form. So the slope-intercept form, like we learned last time, tells us where our intercept is and what our slope is. What is our intercept? Somebody in this back table, AJ's table, what is the intercept for our green equation? AJ's table. It is 1 because this is 3/4 x plus 1. The B is your intercept. So 1. So I'm going to draw a point at 1. Your slope is up 3/4. Your fraction tells you your rise over your run. Up 3/4. Up 3/4. Down 3/4. Down 3/4. I think I did that right. And then you're going to draw your line. Okay? So that was step 1 for this part of the function. Step 2, find your endpoints. What are my endpoints? One, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. I don't know. What'd I do wrong?
Oh, I think I'm blind. Never mind.
I think it's just that the graph is really small. It's okay. All right. What are our endpoints? This little thing right here tells us our endpoints. What are our endpoints? -4. So I'm going to do, is it an open or a closed circle at -4? Open. So I go to my -4, this line, I'm going to do an open circle. The +4 is also going to be open. So open circle. Okay. So then we say that we erase the rest of the line. So we know it's in between -4 and 4, so we're going to erase the rest of it. Okay? Are we good on that step? Thumbs up if you're with me. Put your thumb up. And shake it. Shake it, shake it. Shake, shake it, shake it. All right, now we're going to do our blue equation. What's our intercept for the blue equation? Blue equation. Someone in this table over here, what's our intercept for the blue equation?
Wait, sorry, say that again one more time.
What is the y-intercept of the blue equation? How do we know the y-intercept? Did you say 8?
Yeah.
It is. So there's our intercept right there. And then somebody, what is your name again? Yeah, I knew that. Hatch. What is our slope for negative 2x plus 8? Okay, so our equation is y equals mx plus b, where b is the intercept, m is the slope. So this is the equation. This is what's similar. Negative 2x plus 8. Which part of it is the slope? Yeah, what's in front of the x? Negative 2. Our slope is negative 2, which means we go down 2 over 1. 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 Okay, so we drew our graph. Now we need to find our endpoints. What are our endpoints? Four is a closed circle. Fantastic. And 7 is a closed circle. Okay, so our graph is in between 4 and 7. That means we can erase everything else. Step 3, erase everything else. So that is what your piecewise graph is going to look like. We know from negative 4 to 4, it makes this line. I just spit, sorry. And then from 4 to 7, it makes this line. Open circles, closed circles. Any questions? The 7 was at the end of this. How did I find it on the graph? I graphed this line, so I knew that my intercept is 8. I graphed it. Then I went to the 4 and 7 and erased everything else. Another way, okay, she asked a good question. How did I figure out that that 7 was that point? What's another way to do it rather than just graphing the whole line? How can I figure out where 7 is on this line? What is f of 7? How could I find, do you know, how could I find f of 7? We've been doing this the last couple times. If I take an x and I want to find the f of it, f of 7, where do I put the 7? You put it in for x. So if I want to find where my 7 is, I can do this. Negative 2 times 7 is negative 14 plus 8 equals 6. So let's check. 7, sorry, that's negative 6. 7, negative 6. Yay, we did it right. So on your calculators, for sake of time, I'm going to show you just from the other equation, because I want you guys to practice this. this is the, these are the sub-functions. Hey, will somebody go and move my mouse? Make that pictures go away. Thank you. So these are the sub-functions for another problem, right? So after you insert these and you put them in fractions, show their boundaries, you do graph. And that's how it graphs a piecewise function for you. So everyone's going to follow along while we graph.
So like, since you got that, right, you have to do the
No, if you have your graphing calculator and we tell you to graph it, you do not have to. I would find your endpoints though, so that you know if they're closed or open circles. This doesn't show you the closed and open circles very well. So let's go ahead and do the graph on the next page, the f of x with the squiggly x.